And that is the point, Sjoerd, where I give the word to you. To introduce you a little bit, you work in the National Institute of Public Health and the Environment, like I do. And Sjoerd is also a data analyst, so he's actually doing a lot of fun stuff and interesting stuff with air quality data, so that it can also be applied for our official tasks, which is monitoring of air quality. And I'm sure you're going to explain the rest yourself. So please take the floor.
All right, thank you, Hester. Let me see. Let's start with sharing my presentation then. Hopefully, you can see my screen right now. Presentation. And I titled it "Investigating the Added Value of Citizen Science for Air Quality Monitoring," because what Hester said, that's what I'm doing. So my name is Sjoerd van Ratingen. I did work at the Dutch National Institute for Public Health and the Environment. And I'm looking into air quality sensors and their uncertainties, and how to calibrate them if needed, and also how to combine them, for example, with calculation models. So a little animation here on the screen. I will get back to that. So since a very long time, RIVM has been monitoring air quality data. We do that because it's identified as the single largest environmental health risk. For health, and RIVM has been doing that, of course, since historically using LML stations. These are official measurement stations, and you can see them here. So let me go back. I'm trying to get the red dot here from my cursor, but here over the country on the right, I hope you can see my mouse. There's a lot of LML stations, which is the official measurement network, and that's how we monitor air quality in the Netherlands. Then about 10 years ago, there was interest. We noticed that also citizens were measuring air quality. I think Hester was one of the first to cooperate with these citizens. We decided to go and talk to them and see what their problems were, because we also thought it was a very nice opportunity to raise awareness about air quality among citizens. And we were starting to think, okay, how can we cooperate with these citizens to have them aware about air quality, make them aware about air quality, and maybe also there's something in for it ourselves to learn from this. And this way, our platform was born. It's a citizen science support platform, which gives you information about citizen science, news, for example, if there's new groups participating in some part of the country. It's a meeting place where you can exchange ideas, but it's also a data platform, a technical infrastructure on which the citizen scientists, they can upload their data to our platform, and we show it for them, and we do the IT for them. And that way we can work together in a very nice way. And in the process of combining all the data we receive from the citizens, we can also, let's say, play with it, investigate the data, and look at its quality. So if I'm showing two pictures here on the slide, and you can see a picture on the left, that's January 2020, when there were like 1,000 particulate matter sensor kits in the Netherlands. And it was, so it's already a big number. But nowadays, although I think this picture on the right is already 1 year old maybe, there's like 2,500 particulate matter sensor kits. So it's really growing. There are lots of local initiatives which are uploading, which are starting a sensor local community and uploading their sensors to our national platform. And also sensor community, the number of sensors on sensor community, it's a worldwide sensor IT platform is also keeps on increasing. So here you can quite evidently see that there's more and more sensors appearing in the Netherlands, which we can work with. So one example of this, such a local community which pops up so every now and then to contribute is, for example, shown here in this slide. I think, I don't know the time, but I think 2 years ago they decided to join the Samen Meten platform, and it's just a community in the south of the Netherlands, and you can see the area in orange on this map. And they decided, together with I think about 70 or 80 citizen scientists, to form a community, get the sensor, get air quality sensors. As instructed by sensor community, and form a community that way. And here you can see in the picture on the right that this that the sensors, these they're in good agreement with each other. So the overlap is quite good, and you see some peaks which may be local results or maybe could also be malfunctioning sensors. These are typically the things we at RIVM are researching. This is an example. So let me go to other examples. In the picture on the right, I show you two animations now. Sorry, on the left, you can see the Netherlands and the sensors, and it was Easter of last year, this year, I'm sorry, 2022. And I'll pause it. What you're seeing now is wind coming from the northeast. So from the northern Germany, we have the wind direction into the Netherlands. And around Eastern, it's 9th of April, there were lots of Eastern fires. It's a celebration in northern Germany, and they make Eastern fires. And here you can see the red increasing around the time this smoke from the Eastern fires is advected into the Netherlands. It's one very nice example of how you can pick up such things with looking at sensors. And also in this picture on the right, you can see New Year's Eve in the Netherlands. And you can see the southwest wind direction with here in the west of the country having the fireworks, giving large concentrations and gradually moving it to the northeast of the country along the wind direction. So it's also a nice thing that sensors can pick up. Because we can spot these fireworks or maybe Eastern fires, the data is also sometimes used by local policy makers or during calamities, like the fire brigade, or in the Netherlands sometimes at some places, I don't know, makes use of it, monitors using this data platform of the sensors. But okay, if we look at the sensors and we know that some sensors are bad and some are good, how can we make sense of that? So if we plot them over the Netherlands, we plot, for example, lots of sensors, and on the background, like the colors you're seeing on the background, the nationwide coloring, That's a national model that we use to calculate from official measurements, so not sensor measurements, from official measurements. Using land use regression models, we calculate a kind of particulate matter concentration background. And if we put the sensors on top of them in this picture, you can see, well, the colors, they don't match quite good. And therefore I'm sorry, the colors for some sensors don't match quite good. And by our methods of comparing sensors with each other, and for example, looking at which sensors behave bad in comparison with others, or which sensors are all the time high or are consistency low values, we identify them as bad using a plausibility. You can see here in the right bottom. And this is just, so on the left panel, we have all sensors together. And the correlation with the background is not that good. But if you keep only the good sensors, which are no outliers, and we think they are very plausible, the results, you can see that the overlap with the background is better, and the sensors show a much more consistent picture. So that's one of the things we're doing with the sensors. And then we can go even further, giving this slide. When we choose these sensors with a high plausibility, we can use these sensors to improve on our official air quality maps, or at least make them more detailed. So what you have on the right, there's a map of the Netherlands with, again, a calculation model based on official measurements you're seeing here in the squares. And you see the yellow color is from interpolating these official measurements using some kind of land use regression model. And if we then include sensors on top of this map, so fuse the sensor results with these maps, we can fine-tune or get more detail into our air quality map, especially in the northern part of the country, where there are a few official measurement stations. We can see the sensors are able to correct the map and, for example, show an expected increase of concentrations in this northern part of the Netherlands. So that's typically the things we are investigating to see if sensors have added value and where they have added value. It's not that easy, because we know that the sensors, they sometimes have to be calibrated if they are bad. So they can, for example, if there's high humidity, they tend to overestimate concentrations. So we thought of a method to correct for example, the humidity part, or more general, the meteorology part of which influences the sensor and which should not influence the sensor. And for that, we use the official measurement stations. So we need our official measurement station network to calibrate the sensors. We need them both, the sensors and official measurements. So how do we go about doing this? We use sensors which are close to official measurement stations, which you can see depicted here. And we calculate correction factors between the measurements close to these stations, and use these correction factors, interpolate them again over the whole country, and use this interpolation field to calibrate the sensors which are not close to official measurement stations. Another example is what you can see here in this picture. We are testing different kinds of calibration methods, RIVM, together with European colleagues, and Fermo, that's a European project. We're looking at applying synthetic data to test the sensors. And we can clearly show in this picture on the right that there's a correlation of the sensors with humidity. So in this picture, you see the estimated difference. So it's a difference between the real concentration and the measured concentration by the sensor. So the raw sensor, the uncalibrated sensor, shows in the middle of January here, this part, it overestimates the concentrations. The difference with real concentration is much larger than 0. And with our method, we can correct for that overestimation, arriving at the blue line. And to show you once more that it seems to be very correlated with humidity, because the humidity in the gray line, it shows the same trend as the raw sensor data. So the raw sensors are measuring humidity for a large part in this case, and not particulate matter. You have to be very careful and correct for that when it's applicable. Yeah, this is also to mention once more that we're using a lot of sensor community data, also from other, so our data platform is a combination of sensor community data and all kinds of local initiatives. For example, Rotterdam, the city has 300 sensors. I just showed you a little community adding 80 sensors. So it's a whole collection of sensor data from different sources, but a large part is coming from sensor community, from which we just use the API to get their data in the Netherlands and then do some calibrations upon it. And the sensor community sensor kit, you can buy all the components for, I think it's even less than 50 euros. I think I will, I think I talked for 10 minutes now, so please let me know if there are questions, and I will not stop sharing yet. Maybe there are questions about some pictures. So.
Yeah, thank you, Sjoerd. I think we see a question already from Falco.
All right.
Sure. Thank you for the very nice presentation. I was wondering, this calibration that you do on the citizen science sensors, you use the LML network for it, but could you expand this network with maybe measurements from the Meteorological Institute, KNMI, to make a spatially better correction? Or have you looked at other sources to increase the amount of sort of reliable sensors to calibrate with?
Well, for these sensors, particularly it's the SDS011 type of sensors, we use what is called implicit. It's called implicit calibration. That is, we are saying, okay, we don't know. We think it's humidity, but the sensor could also be distorted by a lot of other things we just don't know. So we get the correction from comparison with official measurement data, and they are measurement data of air quality, of particulate matter, and at this moment not any meteorological parameter. So it's really got to be for this method. There are other methods which we're also investigating, but for the method I just showed you, it's implicit correction using the air quality, the particulate matter official measurement network in the Netherlands. And that way, meteor information would not improve this method, but maybe others we are investigating.
Cool, thank you.
All right.
Other questions, please? Yeah, Imme.
Hi, thanks, Sjoerd, for the presentation just now. Sorry, I had a little bit trouble entering the meeting, so maybe I missed this part, but I saw on the picture one of the overview maps with the LML stations and the calibration, I think, factor, that some of them were really high and some of them were low. And maybe you already answered my question a little bit in what you just said. Is that factor based on the humidity in an area?
No, this factor is it's implicitly based on the humidity, I think. But it's in a sense that if around a official measurement station, it's very humid.
Yeah.
It will increase the sensors also in the vicinity of this official measurement station.
Yeah.
But it will not, this humidity, of course, increase the official measurements themselves. So you get a difference between the average concentration of the sensors surrounding this station within, say, 5 or 10 kilometers. That's typically what we're using. And we call that a correction factor. And we think, and we suppose, but we can also show there's high correlation that this is caused by meteorological circumstances.
Yeah, yeah. So that would mean that, for example, because I think I saw, could you maybe pop up that one image one more time? That around the Eimond region, I suppose. Yeah, that they are, yeah, exactly. My assumption is that the closer they are to the water, the more influence the humidity level has on the measurements. Whereas if you go more inland, this is less of a problem.
I'm not quite a meteorologist. I think it's relative humidity. It's not the humidity itself, but it's relative. So it's the percentage. Never looked at it. This could be an interesting question if the coastal regions need more corrections in general. I haven't looked particularly into that.
Okay, I would be interested in that, of course, especially around the Tata Steel area. It's an interesting question. But,
yeah. There's a lot going on. That's for sure.
Thanks. Thank you.
All right. There's one more question. Let's see. Oh no, there are.
Akim, I think.
Yeah, can you hear me?
Yeah.
Yeah.
Perfect. So thank you for the presentation. I have one question because at the moment we are working on global co-location, and one thing we want to look into is like different particle compositions. So basically, like traffic related PM 2.5 versus maybe industrial versus maybe urban or sandstorms, or like, is that something that you consider in your model, like, or not at all?
I don't think the SDS 011 sensors that I just showed you are suitable for measuring this. We do combine, like I said in the beginning of my presentation, we do combine the sensors with models. So, for example, if you're very close to a road, you can the model will show you some slight increase for particulate matter, and maybe sensors can also see that. But we have currently no method of I don't know if that's your question, if using a particulate sensor, which is more suitable for road emission, and a particulate sensor that's more suitable, for example, for industrial emissions or something like that. That's not what we're doing at this moment. It's to be kind of hard, I think.
Yeah, my question was slightly different. It was more like, when you have the sensor at specific locations, do you tag them as, okay, this is a rural location, this is an inner city location, and then in your, let's say, calibration model, you might have different factors or different correction factors based on the location of the or based on the particle composition in that location. I mean, that's something we are actually at the moment investigating. So, and we see some differences, but on a bigger scale. I mean, the Netherlands is probably a pretty homogeneous area in that respect. But if you compare, like, for example, New Delhi in India, which has these really like massive traffic, and from stubble burning, wildfire smoke, versus traffic or other things. So that was more my question. Like, are you tagging the locations and then having maybe different compensation algorithms based on the main particle composition you expect at that location?
It's not in the metadata. Like it's not in the metadata. This is a roadside sensor or so. But we give them we give instructions on how to install the sensors. But corrections that I just showed you to the official map, which is based on official measurements, that's a background map. You will not see street locations popping up there in the map. So in sensors with hanging close to a road should not pollute this area. But the fact that it's a background map, that the sensors correct the background, is also taken care of for one part because we just have very many sensors. So the average of a group of sensors in a province or in it should give you a background impression. And if there's some street sensors disturbing the result, maybe I can say that we take it for granted because we go for the high numbers.
Okay, thank you.
Michael or Michael.
Hello, my name is Michael. I'm from Czech Republic. I have a question. Thank you for your presentation.
Yeah.
You said you're taking the data from only the SDS011.
Yeah.
So it's the selected. What about the SPS 30, the sensorions? You don't use that data at all. I'm interested in comparing the measurements of these different sensors.
No, we are using the SPS 030 right now.
Okay.
For maybe I didn't mention that during my presentation, but the calibration is done only for the SDS 011. So it's not for the SPS 030. The calibration method, which I just showed you, is suitable for one type of sensors, as it should be. Another type of sensor, like the SPS 030, should require, because there is a little different sensor, another calibration or maybe no calibration. And we are in the process of investigating that right now. Fact is that at this point there are a lot more SPS 011 sensors in the Netherlands and a few, but growing SPS 030. So we're in the process of looking at a suitable calibration for the SPS. Yeah.
I'm looking at the numbers. This is 1697 from the sensor community network, and the SPS 030 is 149. So
yeah, it's this kind of but I think it's increasing rapidly right now. Yeah,
exactly. Yeah. Thank you.
Thank you.
More questions?
No more hands. No.
Maybe I can ask Michael then. Can you tell me a little bit more about the Czech Republic?
Yeah, about citizen science. Well,
yeah,
I am the citizen science ambassador for the Czech Republic. We have a small NGO. We started basically with the sensor community.network 2 years ago. So we have 125 sensors now operating, and mainly I started an NGO and we focus on sensor building workshops with kids in schools. And now I'm starting a second round of NO2 measurements with passive samplers, with cooperation with the Czech National Hydrometeorological Institute. That's nice change, because we did it in 2022, first time the NO2 measurements with for a year, straight year. So that was never done here before. So, but with the PM measurements, it's a new thing. We focus on schools, and another entity is like do-it-yourself enthusiasts, which is quite big in Czech Republic, because people were always doing things with their hands here by themselves. So yeah, we try to promote that and raise the awareness in citizen science.
Okay, that's great. Great development.
Thanks.
The calibration method that Sjoerd described should be able to work also in other countries. If you have access also to the official data, which is, I guess, the largest challenge there.
Exactly. Our data is only in tables, and if I want the data from official sources, I have to pay for them. But I'm scraping them from the JSONs and saving them in my data repositories. But it all takes lots of time. I was watching Salmon Method a long time, well, 2 years ago, I found out. So I was very interested in this cooperation and integration official data with the citizen science, because of course that's the problem we are facing. And I don't think it's really, I like the solution of RIVM, but it's still a long road ahead for us to make a really use for it, I think, because all the sensors are different. I mean, we don't know where they are placed. Of course, the meteorological data, humidity, that's big obstacle. So thank you for your work, and for being. I like to be in this group, I hope.
Yeah, so once more, we are also investigating other calibration methods. This is the one which is implemented on our platform, but there's also things like indeed calibration with relative humidity, which you also should keep looking at, especially when you have very few official stations, for example. That could be maybe a better option. So keep all doors open.
More questions, remarks, clever ideas. No? Well, I guess if we have no more to ask to Sjoerd, I'd like to thank you once more, Sjoerd, for a nice presentation. I'd like to thank everybody for their attention and for the questions. And there's one more thing I'd like to say, which is about the ECSA working group on air quality. There will be an ECSA conference next year in April, and there will also be a possibility for this group then to meet face-to-face. So if you are interested in that, sign up for the ECSA conference. It's in Vienna, so it's a nice location. And right before or right after the conference, there will be a face-to-face meeting for this working group. So then we can just be all air quality people together and talk about citizen science and air quality. So if you're interested in that, or if you want to give a presentation there, just let us know, because then we are going to arrange that for everybody. So Anybody else? Any remarks? Announcements? Because if not, then I'd like to thank everybody again for being here. And I'll stop the recording.